Synthesis of dihydrobocconine. Dihydrobocconine is a benzophenanthine alkaloid that belongs to the family of isoquinoline alkaloids, extracted from plants such as Papaver and Rutasia. Dihydrobocconine has anti-cancer and anti-inflammatory properties. It can trigger apoptosis in various cancer types, suggesting its versatile potential in healthcare. Down below is the IUPAC name and the article reference. I'm going through three reactions, the first one being the aldehyde prepared by Sonogashira coupling, then this bond in pink turning the aldehyde to an olefin, and lastly the closure of ring B via the Mannich reaction. This is the overall reaction of the aldehyde prepared by palladium catalyzed Sonogashira coupling using our precursors, a terminal alkyne and an aryl halide. THF is the inert solvent, and we have two catalysts, our palladium and our copper co-catalyst. Firstly, we're reducing palladium 2 plus 2 palladium 0. Triethylamine does a nucleophilic attack removing a chlorine ligand. This is followed by beta hydride elimination. HCl is then removed by reductive elimination, leaving us with bis-triphenylphosphine, palladium 0. With the stereoselectivity, alkylation is at the more reactive / electrophilic substituent. There are two cycles because we have two catalysts. The copper co-catalyst is used to increase the reactivity. Copper and palladium are used to activate the alkyne. In the copper cycle, the copper iodine complexes with the alkyne to make the hydrogen more acidic, as the triethylamine is a weak base. This forms the pi-alkyne copper complex. Now the lone pairs on the triethylamine can remove the acidic proton, and a copper alkyne complex is produced. In the palladium cycle, we start with the palladium 0 catalyst. The aryl halide goes through oxidative addition to form a new palladium complex. From the copper cycle, the copper alkyne complex reacts with the new palladium complex via transmetallation, as the electronegativity of the carbon and palladium are similar. Copper and iodine are removed to reform the copper iodine catalyst. Now we are left with a trans complex where the ligands are trans to each other. The next step in the cycle is trans-cis isomerization. This is where the cis isomer is formed for reductive elimination to give us our final product and reform our palladium catalyst. The second reaction is the formation of an olefin to an aldehyde via the Wittig reaction. Triphenylphosphine reacts with the alkyl halide via a nucleophilic SN2 attack. The alkyl phosphonium salt formed is deprotonated by hexamethyl disilazide. This then forms the ylide. Carbon electrons on the ylide attack the electron-deficient carbon on the aldehyde. Electron density shifts from the carbon-carbon double bond to the oxygen atom, and a neutral compound is formed. Following this, electrons on the oxygen atom attack the phosphorus ion to form a new bond and box-like intermediate. The oxygen atom shifts the electrons from the carbon-oxygen bond to form the double bond in the triphenylphosphine oxide. The phosphine then gives up its electrons, and the electron density shifts towards the carbon to form the olefin. With the stereoselectivity, the Z-alkene is produced, as a negatively charged carbon does not have a group which can resonate and stabilize the ylide. The last reaction is the intramolecular Mannich / oxidation cascade reaction. Here we are forming a ring between the amide and this ring here. This reaction occurs under a nitrogen atmosphere rather than an oxygen to prevent oxidation of the amine to an aminium. Under the oxygen atmosphere, bocconine would be produced instead. In this reaction, we use paraformaldehyde and trifluoroacetic acid to convert the amine into an aminium ion. The lone pair on the oxygen atom of the ether facilitates the shift of electron density towards the aminium, reverting it back to an amine. The hydrogen on the carbon redistributes its electron density towards the ether, leading to the removal of the hydrogen atom and the reformation of the stable ether. This process forms the synthesis of the desired molecule dihydrobocconine.